In this example, we will find all real or complex solutions to the quadratic equation x squared equals negative 81. So we'll begin by writing down the equation we're solving, x squared equals negative 81. Because there is only one variable term in this equation, and that is the one that's squared, and it's already isolated on one side of the equation, we can apply our square root property. If x squared equals negative 81, then x either equals the square root of negative 81 or the negative square root of negative 81. What we will always be expected to do with any radical expression is to simplify it. The first step in simplifying the first solution, x equals the square root of negative 81, is to separate the square root of negative 1 from the square root of the 81. So I'll rewrite x equals the square root of negative 81 as x equals the square root of 81 times the square root of negative 1. The reason for doing this is that we can separate out the imaginary component on this answer from the real component. We should recognize that the square root of 81 is 9, and that the square root of negative 1 is I. So the first solution becomes x is equal to 9i. On the second possibility, where x equals the negative square root of negative 81, we're going to go through a very similar process. The only difference is the negative in front of the square root. But that's not going to change what happens to the radical component. Negative square root of negative 81 will become negative square root of 81 times the square root of negative 1. Again, separating the negative 1 into its own radical, keeping the real component, the 81, in the first one. To finish simplifying this, we're going to keep the negative in front. The square root of 81 is 9, and the square root of negative 1 is I, giving us a second solution of negative 9i. Again, because we have just solved an equation, we will go ahead and write this in the formal solution set notation, where the solution set is 9i, comma, negative 9i.